In Module 2, we've learned how both the Azure Portal and Azure Resource Manager can be used to create ACS clusters in Azure. The same thing applies to Service Fabric clusters. In this module, we will show you how to create a cluster in Azure and how to create it yourself. In the demo from last chapter, we've seen how the Azure Portal can be used to create a cluster. It's also possible to do this using ARM templates. You can use the Azure Portal to create a Service Fabric cluster, but you can also decide to configure it and then download the resulting ARM template in the final step of the wizard. Another option would be to go to the Azure template gallery and download the template there. Looking at the anatomy of a cluster, you will see a public IP address. Public IP addresses are used when computers need to communicate with each other across the network. A public IP address is a globally unique address assigned to a single resource connected to the internet. A computer that has a public IP address can be reached from anywhere across the world using the internet. The public IP address is connected to the load balancer to make it accessible across the internet. To manage the cluster, the load balancer distributes traffic coming in from the outside world across nodes. Clients running in the outside world take a DNS name that gets resolved into an IP address. This is connected to the load balancer, which forwards incoming requests to healthy cluster nodes. This way, individual nodes may come and go without clients needing to adapt for it. Unlike in ACS, there are no separate master and agent nodes in a Service Fabric cluster. All nodes contain services that define the cluster, and all nodes can run applications. The load balancer forwards traffic to individual nodes using net forwarding, or distributes it across all nodes using load balancing. There is also a Service Fabric cluster meta resource. This resource provides an overview of your cluster. It shows information about cluster nodes, applications, active upgrades, security settings, and more. Azure Storage is Azure's cloud storage as a service platform, and it offers services to store tables, blobs, queues, and files. There are two types of accounts, both regular and premium storage accounts. In this deployment, 5 premium storage accounts are used to store the virtual hard disks of the virtual machines that are used. These are persisted as blobs. Service Fabric is currently limited to 100 agents in a pool, with a maximum of 20 virtual machines in one storage account. Premium storage is used for the best performance. There is also another storage account which is used to store diagnostics information coming in from the nodes. In this deployment, OMS is configured to access this data and generate dashboards from it. Creating a standalone Service Fabric cluster requires you to provision hardware resources upfront. Once you have created and configured the required machines, you can use PowerShell to create a cluster. The required scripts and binaries can be downloaded in a single package, the Service Fabric standalone package. At this time, only Windows Server can be used to create production clusters. Linux clusters can only be created as development clusters on a single machine and as Azure clusters on multiple virtual machines. You will likely add your own public IP address and load balancer to this cluster if you need to run services that are reachable over the internet. In Module 2, we learned that an ACS cluster can consist of 2 agent pools, a public and a private pool. This was done by putting a private agent node into a different subnet. A similar setup can be created in Service Fabric as well, using placement constraints. Placement constraints can be used to isolate workloads from each other, lift and shift existing applications into ASF, and to run services on a specific server configuration. Placement constraints work in 2 steps. First, add key value pairs to cluster nodes. Creating a web and a worker pool can be done by creating 2 VM skill sets in the cluster and marking VMs in one as web nodes, these are the blue nodes in the image, and VMs in the other as worker nodes, these are the green nodes in the image. Second, add constraint statements to your service. Creating a service that must run on the web pool would have a constraint statement like node type equals web. Service Fabric will take care of the rest. Services that were already running will be moved if needed, and for new deployment, services will be placed on the proper nodes immediately.